Hello everyone. Now we are back with the third chapter of this series, and this we will be talking about the modern symmetric key cipher that we have in cryptography and network security. Let's start. When we talk about it, modern block ciphers are the ciphers what we use for the block amount of data that we have. In this modern block ciphers encrypts a n bit of block of plain text or decrypts an n bit of block of ciphertext, the encryption or decryption algorithm using a k bit key. In this, the n bit block depends upon the n value depends upon the data that has been transmitted and the algorithm that we are using for encryption and the decryption purpose. When we are doing this, we basically have a stream of data. The stream of data is made as the small chunks of data, and this chunks of data can be a block of it containing the data which needs to be transmitted. These blocks of data will be enciphered and then deciphered as per the key and the algorithm that we have. So when talking about this, we have a basically an n bit of plain text of data which is getting encrypted by the n and getting into an n bit of ciphertext. While doing this encryption, and a k bit of key is used to it. That is basically called a modern block cipher. When we are talking about it, it has two major components to it: P boxes and S boxes. P boxes stands for the permutation box. This permutation box helps us to permutate the data or the traditional transposition of the cipher that we used to have. It helps in transposing the bits, like let it be expanding it or shortening it or giving it a straight way. This is how the P boxes are used over there. Next comes the S box. In S box, the substitution box can be thought of as a miniature of substitution cipher where we can substitute the datas over there. Now when we are talking about P boxes, these are the three types of P boxes that we have: a straight P box where we have a data equal number of inputs and equal number of outputs. See, you can see that we have 5 inputs and 5 outputs which are getting enciphered in over here and getting transmitted whichever empty place slots we have. When we are talking about a compression P box, the value input paths would be more than of the external output paths. So all these data will be transmitted over there, and some of bits of the data will be captured and stored over there. When we are talking about the expansion P box, what will happen? The data that we have in input will be lesser and the output will be more. So a single amount of data can be transmitted from multiple ways. So in this, another important things comes the exclusive or XOR that we use. This XOR would be used for the encryption and decryption both the places when we are doing with the plain text or the ciphertext with that K block of key. That K block of key always gets into that plain text or the ciphertext for the encryption or the decryption purpose respectively through that K bit of block. Then only data will be converted into a proper cryptographic uh, text or the cipher text or the getting back into the plain text that we have. So when we are talking about circular shift basically means when we have a data, these are shifted over there. For an example, before shifting, this is the block of data that we have, and if we have a key over here which says it we shifted 3 bits over there. So as these 3 bits are shifted at the end of it, from the beginning to the end. Similarly, we have that was shift left, and same we have the shift right, where the right available values get shifted to the left hand side by 3 bits of it. So we talk about swapping basically means the chunk of data, the block of data that we have is break into two parts, and the left part goes to the right, that you can see over here. The left part goes to the right and the right one part goes to the left. This happens in the encryption part and decryption part, the vice versa of it, when the next block of chunk goes to the other side of it. These things we will be able to see in the DS in the upcoming classes. So next comes the split and combine. The same two blocks of data are split into two parts to do the different operations. And the when we are talking about combining those two chunks of data into one. So basically, when we are talking about the modern block ciphers, the all product ciphers, but they are divided into two classes: feastal cipher and non-feastal cipher. Feastal ciphers are basically where we have a mixer which will help us to mix the key element with the plain text over there. to get the first ciphertext. And in this you can see what will happen. It is in a more improved way where we have a full chunk of data which has been divided into two parts, left and one right. The left part directly comes over here and the right one parts comes up with getting element key, the key element, getting into it and getting it mixed with XORing with the left one side, and we are getting an L2 over there, whereas R1 is used over there for the mixing with it, and it goes directly to the its own same block. When we are doing the decryption, the same alternative way will be used. R2 will be going back to its place, R3 will be going to its place directly without anything, exactly the same thing. The algorithm will decide when, which part or how the chunks would be divided into. And L3, when it comes, that R3 data that we have is again combined with that key and XORed with it and take out the L4 value. So again we will get back the same value back as over here. So this is the encryption and the decryption part of the feastal design that we have. So this is a complete feastal design of a two surrounds over there. When you can see an L1 over there and an R1 over here, R1 comes directly over to the swapper, whereas mixer, it in the mixer the R1 gets included with the key element that we have, the first key element. We're getting XORed with it, coming to the swapper, exchanging their position. Just make sure the swapper me exchanges the position. The right hand side goes to the left hand side, the left hand side data goes to the right hand side, and again the same process happens where R2 data which has been swapped right now will go directly to R3, and the R2 data will be included with the K2 element and would be XORed with the L2 element, and we are getting back our full block of data. Same way the vice versa, the operation will be included or used to get back our data at the beginning position. So one of the example of it is the blowfish symmetric block cipher designed by Bruce Schneier in 1993 and 1984, with having a characteristic of 16 rounds of encryption, fast implementation, simple structure for analysis and implementation, uses 32 to 448 bit key. Variable security by varying key size, allows tuning for speed, security, and trade-off of the data that we have. Next comes the non-feastal cipher. In non-feastal cipher, we do not include anything separate other than that. Basically, in this, what we do, whatever the data or chunks that we have, whether we divide into two parts, and that is only used with the two parts. As we read over here, a component in the encryption cipher has the corresponding component in the decryption cipher. So whatever the data we have, that is only mixed with each other. No other external elements are included. That same data is used in the same way. Next we have the modern stream cipher. In the modern stream cipher, where the cipher encryption and decryption are done on R bits at a time. So whatever the R bits of data that has been taken or is going through the stream cipher will be used and will be practiced at every each perception of seconds as per the algorithm. It will be taking and converting it into the cipher text. So here is a one diagram for synchronized stream cipher. In this we can see where an encryption data has been taken, where a random sequence bit generator will come and XOR with the plain text the data that I have. Here the I basically means the specific R bit of data that we have. When we have this R bit of data, for an example over here is taken as 1 bit. So 1 bit of random sequence generator value is taken. After taking it, it has been XORed, and that XORed value is transmitted. That 1 bit of data is transmitted to the insecure channel. It can be an insecure channel, it can be a secure channel. It depends upon the channel that they are both the source and the destination is choosing to transfer the data. So when we have transferred it, that 1 bit of data comes to the receiver's point and he wants to decrypt it. For decryption part, he will again use the same bit of key over here, taking from the random sequence bit generator and XORing it with to get back his plain text back. So this is also called the one-time pad, where all the data are being done at every sequence of time. Then comes the non-synchronous stream cipher. In a non-synchronous stream cipher, each key in the key stream depends on the previous plain text or cipher text. In a non-synchronous stream cipher, the key depends on either the plain text or the cipher text. So here the key is completely depending upon the thing. So that was all about the modern symmetric key cipher that we have and how it can be used and how it can be modified, and what are the modern stream symmetric key cipher. Do look through it, because in the further upcoming classes when we are talking about AES and DES, we would be going through the same things. I hope you liked it. If any questions, any doubts, please put up questions over there in the comment section, and we can have a further class on it. Thank you.